All right, this video is going to go over pages 14 and 15 in our Kinematics 2. So we're going to continue on the velocity versus time graph practice. Now this one's going to be more conceptual, so kind of ask some questions that don't really deal with actual numerical values, but we'll just kind of look at graphs just for the sake of looking at graphs. So we're looking at a velocity versus time graph. Okay, so we got to pay attention to one, your y-axis is now your velocity. It's not position anymore, so we got to get that kind of stuck in our head that our y is now velocity, and our x is still time. Okay, so that doesn't change. And then our slope is going to equal acceleration. So that is when we are speeding up or slowing down. So if I ask you anything about just velocity and only velocity, all you gotta do is just look at the y-axis. Okay, where are you on the y-axis? How much do you change in the y-axis? If I ask you anything about acceleration, then you can start looking at the slopes of the lines on the graph. So number one, it says, which cyclist is traveling faster at 3 seconds and how do you know? Okay, so if I want to know who's faster, that's velocity. That's not acceleration. Acceleration is how fast are you speeding up. I just want to know who's going faster. So if you look at your y-axis is velocity. So let's say like this is your 0 line. So you got like 1, 2, 3, 4, 5. Those are all velocities. So at 3 seconds, we want to know who has the highest velocity. So at 3 seconds, that's going to be B because B is higher. Okay, so it has a higher velocity at that time. Now, number 2 says, which cyclist is traveling faster at 7 seconds? So we're going to keep going towards the right, and we're going to see who's higher at 7 seconds. And that would be, now it's A. So A would be faster because it has a higher velocity at that time. Now 3, which cyclist is increasing its speed? So increasing its speed is a fancy way of just saying acceleration. Okay, so it's faster. Which one's increasing their speed or accelerating faster at 3 seconds, and how do you know? Well, that's slope. So who has the steepest slope? So in this case, A is going to be steeper. So A is going to have the fastest or increasing speed the fastest. Now what's happening at 5 seconds? So at 5 seconds, what's going on is if you look to the left, they're going to have the same velocity. Okay, not the same position. That's easy to mix up because that's what we talked about in the last unit. But A and B could be totally somewhere different. A could be somewhere and B could be somewhere. So it really has nothing to do with their position. We're just looking at their velocity and how fast they're going. Okay, so at 5 seconds, they would have the same velocity. 5, which object is increasing its speed faster at 5 seconds? Okay, so again, increasing speed means acceleration. So who has the steepest slope? That's going to be A again. Okay, so in this graph, B is never going to be accelerating faster than A because B is always going to have a flatter slope than A. Now, in the beginning, B was actually faster, okay, because it started off with a higher velocity, but A caught up quickly because it had a higher acceleration, and then after 5 seconds, A was faster than B. That's because A has a higher acceleration. Going down to the next one, now if you look, A still has a positive velocity that's increasing. So this means you're like speeding up forward. Okay, so you're speeding up in the forward direction. Now if you look at B compared to the last graph, B is now going towards 0. This line right here, this x-axis, is 0 meters per second. And if B keeps going, so we're going to pretend B is an arrow, that means you're going towards 0. So B is actually slowing down now. Now it's still going forward because it's above the x-axis. It's just slowing down. It's going towards 0. So number 1, how does the motion of cyclist A in this graph compare to that in A in figure 1, so the last graph? They're pretty much the same. Okay, I've looked at both of them. They look like pretty much the exact same slope, same direction. Okay, so they're both speeding up in the forward direction. Now number 2, how does the motion of cyclist B in this graph compare to that B in figure 1? Well, now B in the first graph actually had a positive acceleration. It was going up, so it was accelerating. Now, if you look, it's actually decelerating or it's slowing down. Okay, so it's slowing down now. Both are still going in the forward direction because they're both above the x-axis, but now B is just slowing down. 3, which cyclist has the greater velocity at 3 seconds? So again, remember, your y-axis right here is your velocity. Okay, so at 3 seconds, who's higher? Well, that's going to be B. So even though it's slowing down, at 3 seconds, B has a higher velocity than A. Number 4, which cyclist is traveling faster at 7 seconds? So at 7 seconds, that is definitely going to be A that's faster now. Which object is increasing its speed faster? So if we're looking for slope, that's acceleration. Okay. Now A is the only one that's actually increasing its speed, so that's a dead giveaway. But if they're both kind of going the same direction, we'd still just be looking at who is the steepest slope. So A is definitely going to be the answer for this one because its acceleration is positive and it's still steeper than B. 6, which object is increasing its speed faster at 3 seconds? So again, no matter what, A had the steepest slope the entire time. Okay, so A will always have the higher acceleration. It may not always have the highest velocity. It didn't in the first 5 seconds, but it had the higher acceleration the entire time. So your answer is going to be A. And that was it.